either one of those two is paying you, then you are doing a route leak yourself. So, as I said, it's a big discussion to talk about route leaks. If you want to see different types of route leaks, you can check this RFC 7908 for more details. Now, the challenges, here I have in bullets some of the challenges related to hijack and route leak detection. Some of them, one of them is speed, because the fastest we are able to detect an event, the fastest we'll be able to mitigate it, and possibly we might not even allow it to propagate to the rest of the internet, depending on how fast we are. Another very important challenge is accuracy, like to avoid having false positives and false negatives. Another challenge is evasion. Basically, hijackers have the ability to evade attacks, to evade being detected, basically. That's the correct way to say it. And also, there is a challenge related to privacy and flexibility. What do I mean by that? Networks, if they need to share to third parties their routing policies, their neighbors, their network configuration, basically, they are they do not want to do that. And this is related to the privacy need that each network has to keep stuff in-house, so they are not conducive to share this information with third parties. And all these challenges that we mentioned in the previous slide, we tried to tackle them with the Artemis implementation, with the Artemis paper and the Artemis open source software that we mentioned before. This is the URL for Artemis, for everybody who wants to take a look. And Artemis is a non-premise tool we developed. We support currently a community of users as a contribution to the community. It's a precursor of the Code BGP platform. It's a collection of loosely coupled microservices that you can download and run on your own servers or on your own Kubernetes cluster. And whereas the Code BGP platform that we developed is a commercial product, and we did it because we wanted to expand the scope beyond hijacks and beyond just security events, and also to provide more features, more flexibility, and more observability, I would say, to the network operators. But what both of them have in common is that they are self-operated. Basically, each network has their own instance that they run either on-premise, in the case of Artemis, or on the cloud, in the case of the Code BGP platform. And what we do, the way we avoid false positives and false negatives, is by leveraging the contextual knowledge of the network operator. Meaning the network operator knows what are his autonomous systems, what are his prefixes that he's announcing, what are his neighbors, usually, most of the times they know that, and they can configure the platforms with this configuration so that whenever something else shows up in the internet, it will be detected. The Code BGP platform this is a graphical representation on high level how it works. On the bottom, we have the data services, we call them, that provide data to the platform. And these are 1,600 monitors, BGP routers, you can imagine them. Basically, they are BGP routers. Both RIS Live and the Code BGP monitor that we will describe in detail in a bit. You can also connect your own routers to the platform via BGP or BMP feeds. And also RPKI is another source of information. And we gather all this data and we build the state of your routing resources. What you are currently announcing, this is, you can imagine it as a big looking glass from 1,600 routers, instead of having one router that is a typical looking glass. And on top of the state, we provide various features, alerting that we will focus more today in the alerting feature. We provide automation, and we also provide dashboards. So speaking about the data services that are in the bottom here, one by one, to explain what these are in more detail. The first one is the Code BGP Monitor, which is a monitoring service that we developed. And it is based on iBGP and route reflection. So all these dots that you see in the map are one or multiple routers in each city that run iBGP, and they do route reflection. Why is that? Because we want to know for each update where it came from. So by doing it with iBGP and route reflection, the next hop is not altered. So we gather all these updates, all these routes in our route collectors, and we know for each one where we got it from. And then from the route collectors, we want to propagate all the routes that are relevant to each user related to their autonomous system and prefixes to their own Code BGP platform instance that runs on Google Cloud specifically. So how do we do that? In order to not let BGP do its work and basically hide all the alternative paths and provide only the best path, which is what BGP does normally, we enable the add path capability so that we provide all paths without any, what I mentioned before. Currently, we have 186 full feed peerings, both V4 and V6. We have 93 routers all over the world. We have 20 upstreams, and we are present in 37 countries in 62 cities all over the world. Another data service is RIS Live that provides a JSON WebSocket API that you can tap and get data from 1,448 routers. That's what I counted last October when I did this exercise. Maybe these numbers have changed a bit by then, since then actually. And out of which half of them almost are full feeds, full BGP feeds. And RIS Live is like a community project that we all should support because it gives great BGP visibility in BGP, both for network operators and for researchers. You can see the list of route collectors of RIS in this URL, and also the list of peers. The 1,400 plus peers that I mentioned is in this URL as well. And everybody can use this to do like custom BGP monitoring. Another source, as I mentioned, is your own routers. Your own routers can be connected, as I said, via BGP or even a BMP feed, so that we get the routes that are like outbound from your routers to the rest of the internet. Another source, another data service is RPKI, where we track the state of ROA certificates and validate updates from the 5 routing registries. And the types of alerts that we support are multiple. I would say we have a comprehensive list of alert types that we support. If we want to categorize them, there will be exact subprefix hijacks, route leaks, like these are related to security, typical stuff that we mentioned before. The new neighbor and neighbor leak hijacks are interesting because they are both related to the type 1 hijack that I mentioned in the previous slides. The difference between them is that a new neighbor may show up that you don't expect them to peer with you. This is the new neighbor alert. But a new neighbor showing up in BGP without propagating your prefixes is not an attack on its own. It's just that it might be the beginning of an attack, but it's not an attack. The actual attack is the neighbor leak hijack that is right underneath, where the new neighbor not only shows up as a first hop neighbor of yours, but also propagates your prefixes. This is a distinct difference. We mentioned squatting, what it is. Presence in AS path is another alert where you can be informed if you want to avoid, for example, specific AESs to be present in your AS path, or even AESs from specific countries that might be present in the AS path. You can be alerted with this rule. Invalid AS path pattern is another rule where if you know like your AS paths in 2-3 hops away, you can encode them with regex, and whenever a new AS path shows up, you will be alarmed. Alerts related to prefix visibility and peering visibility. Alerts related to RPKI. Alerts related to bogon prefixes and AESs. And also, we do comparisons between various data sources. So we mentioned, for example, you can connect your own routers or RIS Live or the Code BGP platform. You can do comparisons of these sources, what they see based on the AESs and the prefixes that you want to monitor. And also, you have the ability to do custom alerts by using a very powerful API that we have that I will present in a bit, which is based on GraphQL. And what is GraphQL? GraphQL is a query language for APIs that was developed by Facebook and open sourced by Facebook. And if I want to highlight two things about GraphQL that are important, is that, first of all, you ask exactly the data that you need. It differs from REST that gives you back everything and you need to filter what you need. You can ask for exactly what you need. That's a distinct difference. And also support subscriptions. That is another very important feature that I highlight in this presentation. And what do we mean by subscriptions? Subscriptions are a GraphQL feature that allows a server to send data to its clients when a specific event happens. So usually when you have like a database storing data and you want to see the changes in the database in the previous approaches, you need to query the database at every specific interval. For example, every 5 seconds, every 10 seconds. Do you have data? Do you have data? This is not obviously, doesn't scale and it's not very efficient. So the idea of GraphQL is that the client opens up a long-lived connection, a WebSocket, where by sending a subscription query, and every time a particular event happens, the server pushes the data to the subscriber. So this is much more efficient, and this is where we based our entire, the Code BGP platform is entirely based on GraphQL subscriptions. So you can create an alert using the UI, but this I will show you with a live demo. And this is how a GraphQL subscription looks like in code. For example, for an exact prefix hijack rule, for prefixes that belong to our own network, the Code BGP AES 5414. So the way it looks like is it's basically a mutation. A mutation in GraphQL means it's an edit that inserts a subscription, as I mentioned, that does the exact prefix hijack detection. So moving along from the technical stuff, we have like an instance of the Code BGP platform monitoring the root DNS servers, which are the authoritative name servers that serve the DNS root zone. And here I have listed all the root servers and their IPs, and also the operators for each one of them. And you might wonder, why monitoring the root DNS server prefixes, right? So there are multiple reasons behind why we do it. One reason is that it's critical internet infrastructure and it's worth protecting. Another reason is that these prefixes are heavily any-casted. So any anomalies, like for example, exact prefix hijacks that we mentioned that do not affect the entire internet, will go largely unnoticed due to their limited impact on the data plane. So these prefixes are heavily any-casted, and I was thinking that probably nobody will ever figure out that there might be hijacks for these prefixes. So we provide access for free to a code BGP platform instance that monitors the root DNS prefixes, also as a proof of concept of how the platform works. And this slide describes how to get access to the root DNS monitoring instance. I will show you though, like basically you go to this URL, you type public demo, and you sign up and you get access directly to the instance. And in the next few slides, I want to show you some hijacks that we detected since we started monitoring at the end of January 2023, like a couple of months ago. So this AES, this Malaysian AES, announced this prefix, which belongs to the Internet Systems Consortium, and serves as the V6 prefix for the froot domain server. And if you notice, this is the prefix, and this is the origin AES, the network who did this exact prefix hijack. It might not be a malicious event, it might be a misconfiguration. We do not judge intentions. We just present what we see in BGP. But if you see under each resource, and this cuts through our UI that I will show you in a bit, we gather the sources of information where we got it from. So this update was seen by this specific RIS peer that resides in Singapore and is connected to route collector 0 of RIS Live. And it's interesting because this specific prefix is covered by an RPKI ROA, and also this neighbor AES 32001, I checked, and apparently it looks like it's applying root origin validation. That's why this specific announcement did not propagate any further, which is interesting. Like one use case where you see why RPKI is useful. And this is another use case where you see why RPKI is useful. In February 25, this AES, which was also involved in events that BGP-related, security-related events that took place in 2021 and 2020, hijacked two prefixes, one belonging to root DNS prefixes, one belonging to NASA, and it was the prefix for the e-root, and at the same time, also again, the prefix of froot of the Internet Systems Consortium was hijacked as well. These two events happened at the same time with the same origin. And here you see all the routes that are related to these, to both events. And for the e-root, which is not covered by RPKI ROA, the event lasted 2 days. And if you see, the event propagated quite a bit. It was seen by a few different route collectors, both for RIS and by the code BGP monitor. Whereas in the case of froot, again, because it is covered by a ROA, the blast radius of this event was much smaller. And again, you see, as I said, the value of RPKI and why we should all try to implement it. Now, I will switch gears and I will show you how the platform works. Let's go to the URL. Here, for each organization, they need to type their organization ID. I will go to the public demo first. I just need to type correctly also. This is a public demo instance that I mentioned that everybody can sign up and take a look. This is the overview page of the platform where you see routing like aggregate numbers, and I will zoom a little bit, aggregate numbers for the routing resources that this specific instance is monitoring. By routing resources, we mean autonomous systems and prefixes and other related information such as peerings, routes, and ROAS. Here are the rules that are set up for this specific instance to detect events. And on the right side, there are the four sources of the four data services that I mentioned before: RIS Live, RPKI, your own routers. This instance has no routers connected. And this is the code BGP monitor that I mentioned. So how do you set up for the platform to monitor stuff? You go here to the setup, and the first thing you do is you add an autonomous system. If you see, here I have added the autonomous systems that belong to the root DNS servers and also my own autonomous systems. These two belong to code BGP. And how do you do it? I will now add one AES just for demo purposes. This AES belongs to the Foundation of Research and Technology in Greece. When you add an AES here, what the system does, it intercepts all the BGP updates from all the sources that we mentioned before and stores these routes and these prefixes in the database. But other than just doing that, I will remove this because this is a public facing instance and I don't want it to show other stuff. When you add an AES, as I said, we store the updates that contain this AES as origin. But we also need to monitor the prefixes themselves, because if we don't do that, let me add the AES just for demo, as I said, and I will remove it again. So this is the AES that we added. We also need to monitor the prefixes themselves. Why? So that we intercept all the BGP updates that contain this prefix, regardless of who's originating these prefixes. So that we are able to detect like events of interest, hijacks and other malicious activity, or even like for visibility purposes. You need to monitor the prefixes themselves. And how do you do that? Kevin previously added an AES. You can either type the prefixes manually in a CIDR format, or you can select the AES that you added before, and the system will bring you all the prefixes that it has seen from all the sources. Let me show you my own AES to give you an example how it works. These are the prefixes that my own AES is announcing. So now, if you select, you can add them automatically. And now when you add them, you monitor the prefixes and the subprefixes of these prefixes, regardless of who's originating them. So it's very easy to configure the platform to monitor stuff. Here we have the data services, where you can do various configurations, but I don't think we will run out of time if we want to provide every information about the platform, so I will move on a bit faster. As I said, what we do is we capture the state of your routing resources, what you are currently announcing. And here in the prefixes, you see that this prefix belongs to the University of Maryland, which is one of the root DNS operators, and it has been currently seen by this number of sources. And here, this percentage is basically a ratio between how many prefixes, how many sources, how many data sources have seen this prefix, divided by the number of the total number of sources that could have potentially seen this prefix, given the fact that this is a V4 prefix. We do this division and we give this percentage, which is not a scientific number, but gives a notion of visibility, how visible a prefix is. And here, we have the routes that, as you see, that are automatically refreshed due to the GraphQL subscription, because the whole UI runs with GraphQL subscriptions as well. And yeah, this is, you can go and take a look at the public demo for free, as I said. And I will switch gears again, and I will go to another instance of the platform. I will go to the demo instance, where I can do a demo of creating a rule. That's the plan, at least. Okay, I will need to switch my browser because it has been cached. Let me open another browser, and I see that I also stopped sharing. I need to start sharing again. Okay, I share my screen. Can you see me? Can you see my screen? I hope yes. I believe yes. Okay, now we'll go to the demo instance of the platform. This is an instance that we use for demo purposes, basically, just to do demos and stuff. It's the same idea here, aggregate numbers for the routing resources. Let's go and see what we have set up. These are the two autonomous systems that belong to Code BGP. And do I have prefix filter set up? I will remove this prefix and add all the prefixes for both my AESs, so that we monitor them as well. Okay, now we monitor prefixes and sub-prefixes regardless of who's originating them, as I said. And I'm gonna create a rule. I talked like in detail about the rules. We support all these rules that I mentioned before. I will create now a rule related to an exact prefix hijack. And then I will do an announcement to see how the platform detects this hijack. I will call this my own AS exact prefix hijack. You can give like a custom name, whatever works for you. And the next step is to select an autonomous system. So as soon as you select an autonomous system, the platform checks the state of your routing resources and suggests the prefixes that it sees as prefixes that belong to you. So I will basically add my email here. As the email recipient. We support various types of notification channels, basically everything that Prometheus Alert Manager supports, which is more or less everything like Ops Genie, PagerDuty, like Telegram, Slack, email, you name it. So the next step is to preview the alert, make sure that you are happy with the configuration, and you click on Add Alert Rule. As soon as you click the Add Alert Rule, you can see the alert here, the rule, and you can see the configuration when it was created and where you will get the notifications to. So what I'm gonna do now, I will go to the state and I will make sure that this prefix is not visible right now. I will go to the prefixes table, no, not visible. I will go to routes. It's not visible. I will split my screen and I will switch on one router. I don't want you to see all the routers that I have in everywhere in the world, so I will share this screen in a bit. So we will go to this router. that resides in Sydney in particular. So this router resides in Sydney, as I said. And hopefully I will zoom in so that you can see my screen as best as possible. So what I'm gonna do, I'm gonna tinker with the configuration of this router. This is a bed router. And I will delete this comment here. By doing that, I will create a static announcement that is related to this 5 prefix that is the same as the one that I have here. And by doing that, I will basically announce to BGP this specific prefix.
Hi, Lefteris.
So I have done the configuration,
Lefteris.
and now I need to push it. I need to commit it, basically. The command for this is birdsig configure. So take a look. As soon as I click on enter, how fast the platform is in detecting the event. The platform resides in the other side of the world, in the east coast of the US, and this router resides in Australia, in Sydney. And you already see the routes jumping, the number of routes that are related to this specific prefix. And also, you can see the number of sources jumping as well that have seen this prefix. And the number will reach almost 460, 470 sources within a minute. And at the same time, we have also received an alert by email that is related to this event. That it says that this is the alert that you have created, and this autonomous system is hijacking your prefix right now. Yeah, this was my presentation. Thank you very much for your attention, and I would be happy to answer any questions.
Thank you, Lefteris.
I will also unmute my sound because no.
Okay, we've got time for one question if anyone has a quick question. Oh.
Hi there, Ed De Lange from, the internet. I saw in your one slide where you just had all your collectors, and Africa seemed to be a bit of a hole on your map. Is there plans to fix that?
Absolutely. I would love to have more presence in Africa. It's a challenge for us to find providers that will give us. I hear my sound. That's why I switch off my sound. It's a challenge to find providers in Africa. But yeah, since I'm doing a presentation in Zangman, from now on I will have more people knowing what we do in Africa, and more people will reach to us so that we get full feeds from Africa as well. I would really love to do that.
Great. Thank you very much again, Lefteris. Okay. And next up, we have Amrish, who's going to talk about his latest RPKI research.